Hey guys, it's Miss Johnson here, and I'm here to talk to you about how we solve quadratics by graphing. So yesterday we looked at graphing a quadratic equation and how we find the vertex and find the axis of symmetry and make the graph on a coordinate plane. Today we're going to use look at where the solutions are once we make that graph. So just a reminder, a quadratic equation is an equation that has an x squared term. So any equation that has an x squared term gives us a quadratic equation. And these are the three types of solutions to that quadratic. You've got one possibility of a solution. That's when the quadratic equation crosses the x-axis only one time. You could have two. The parabola, the graph of the quadratic, could cross the x-axis twice, or you could have none. It could cross the x-axis no times, and a no solution equation could be down here as well, opening down. So you could have all of those flipped upside down. You could have one that looks like that, and then it has these two, or you could have this, and it could hit on the x-axis. So anyways, one, two, or no real solutions. Those are your possibilities there. So let's talk about how we would solve these by graphing. If we're going to solve these by graphing, then we need to actually graph the quadratic equation. So a lot of what we do today is going to be what we did yesterday. Find the y-intercept, find the vertex, find the axis of symmetry. Then the new thing that we're looking for is these zeros, and that's what we call those solutions. Solutions have a lot of terms. They could be called zeros. They could be called roots. They could be called the x-intercepts. There's lots of different words that we mean for the solution to a quadratic. So let's look at the equation we have. It's already in standard form. I have x squared plus 6x plus 8 equals 0. So the y-intercept, easy. That one's going to be 0, comma 8. Vertex. For the vertex, I need x equals the opposite of b over 2a. That's negative 6 over 2, which is negative 3. And then find the y-coordinate. You'd have negative 3 squared. Don't forget to put that in parentheses. When you have that negative especially, it's important to put that in parentheses. And that's going to give me 9. That's going to give me negative 18. That's going to give me positive 8. So I end up with a negative 1 there. So my vertex is negative 3, negative 1. The axis of symmetry is always the same as the x-coordinate of the vertex, so x equals negative 3. And now let's find the zeros. So put this graph on the coordinate plane. The y-intercept is up at positive 8. Now that's 1 off the coordinate plane that you've been given, but that's okay. We can draw 1 unit off. And then the vertex, negative 3, negative 1. And remember, that's also where the axis of symmetry goes through. So yeah, we can draw our axis of symmetry. And then we know that it mirror images across the axis of symmetry. So we're going to go 3 units in the other direction. And then draw our graph like that. Now we're trying to find the solutions here. We're trying to find the roots or the zeros where they cross the x-axis. So if I look, it seems to me that they're going to cross the x-axis right about there. So that means our zeros are negative 4 and negative 2. So let's take a look at one more example here. We're going to find the zeros one more time with this quadratic equation. But now when we look at this quadratic equation, it's not in standard form. So that's the first thing I'm going to do. I'm going to plug it into standard form. I have negative x squared plus 8x, and then I need that 16 to move over. So I'm going to have minus 16 is equal to 0. So there's my standard form equation. So that tells me that the y-intercept is going to be negative 16. Now that's a really low y-intercept, but we can work with it. Then the vertex, let's find that. I need the opposite of b over 2a. So opposite of b would be negative 8 over 2 times negative 1. That's a little mistake mark there. And that would be negative 8 over negative 2, and that's a positive 4. And then I need to plug that back in and find the y-intercept, or find the y value of the vertex. So I have the opposite of 4 squared. Be careful with that one. You square 4 first and then take the opposite. So plus 8 times 4 and then minus 16. That's going to give me negative 16 because 4 squared is 16 and the opposite's negative 16 plus 32 minus 16, which ends up being 0. So I have 4, 0, and then my axis of symmetry is always the same. So now let's go ahead and graph that. Now, negative 16 is kind of a low y-intercept, but we can start with the vertex. The vertex is 4, 0. And if we take a look at that vertex, even if I'm going to draw my quadratic down to the negative 16, which is going to be way down on my coordinate plane, look at where your vertex is. Your vertex is 4, 0. So we're looking for where this is going to cross the x-axis. Well, your vertex is on it. This is an equation that has only one solution. So our 0 here is just x equals 4. Um, and yeah, so we have one solution. And yeah, only one solution for this quadratic equation. So anyways, we're going to stop our video there and we'll finish up the last couple examples in class tomorrow. Don't forget to hop back to Schoology and take your quiz, and I will see you then. Thanks.